Hello everybody. Welcome to today's Appeon Community Webinar. Today's webinar will focus on encryption and related features of PowerBuilder 2017 R3. These new features of PowerBuilder should help to strengthen the security of your applications. Today's community presenter is Bruce Armstrong, a longtime PowerBuilder developer and also an Appeon MVP. Before we turn it over to Bruce, we wanted to point out that this is a volunteer-based community presentation. As such, the views and opinions may not necessarily reflect those of Appeon, and Appeon has not reviewed this content for accuracy. All right, Bruce, take it away.
Okay, thanks, Armin. First thing we're going to do is go over the agenda. I'll talk about myself for a little bit first, who I am, why you might be interested in what I have to say. And then we're going to talk about the encryption features. Now, by encryption, we're actually talking about a much broader set of functions. One of those is encoding. Then we'll cover symmetric encryption, asymmetric encryption, asymmetric signing, and then hashing. And then we'll have the question and answer session. So first, a little bit about me. I've been around PowerBuilder for a long time, 30 years or so. I started out with 1OB. Once I got familiar with it, I started doing independent contracting, did that for 15 years. And then about 14 years ago, decided to leave independent contracting and went with a company called Integrated Data Services. And I'll talk about them in a minute. You may be familiar with me because I was the editor of the PowerBuilder Developers Journal for a long time and wrote a number of articles for that, or because I help out in community forums, such as the Appeon community nowadays. And as a result, I was made a member of Team PowerSoft, which then became Team Sybase, which then had PowerBuilder MVP and SAP Mentor as well. And I am an Appeon MVP as well. So all that means is I spend a lot of time out there trying to help other PowerBuilder users, doing things like writing a couple books, those magazine articles I referred to earlier, and webinars and user group meetings, webinars such as this one right here. A company I work for is called Integrated Data Services. When I joined them, they had their main bread and butter application was written in PowerBuilder. They've since migrated that to a web technology, and a lot of the other apps we do nowadays is also in a web technology. However, there's a few customers we have that still prefer to use the client-server version, and so we are still actively doing development in PowerBuilder for that application. So enough about me. Let's talk about the different encryption features. And the first one we're going to talk about is, like I mentioned, isn't specifically encryption, it's encoding. There are three methods that are supported now in this new coder object that came out in R3. There's hex encode and decode, base64 encode and decode, and then URL encode and decode. Now what encoding is in all of these various forms is taking data that may have special characters in it and converting it into another format that encodes those special characters, or actually, in the first two cases, encodes the entire string, so that it can be transmitted in a manner that might be sensitive to those special characters. For instance, if you're going to send a document via XML and it needed to have a URL link in it, you would want to URL encode the URL to get the special characters out, because those special characters will actually mess up the formatting of the XML and make it hard for whoever receives it to actually parse the XML with those special characters in there. Now, something to be aware of is all of these functions take a UTF-8 encoded blob and return a UTF-8 encoded blob. The reason that's important is because if you just run the blob function on a PowerBuilder string, what you're going to get back, if you don't indicate the kind of encoding you want, is UTF-16LE, which isn't going to work for these functions. So you want to make sure that you specify when you're converting to and from strings to strings and blobs, you specify you want the UTF-8 encoding. Okay, so hex encoding, let's look at that in a little bit more detail. So in hex encoding, takes each byte of data and turns it into its hexadecimal ASCII value. So, for instance, if we had the phrase, "the quick brown fox jumped over the lazy dog," when hex encoded, it becomes this hexadecimal string. 54 is capital T, 68 is lowercase h, and so on. Base 64 encoding is a little trickier. It takes each byte of data, breaks it into 4 pieces, and then looks up each of those pieces in a base 64 table. And then that's what actually gives you the final value. So using that previous example of the quick brown fox jumped over the lazy dog, what we get after base 64 encoding is this string. And of course both of those support decoding as well. And same with URL encoding. So if we have a string that looks like this, and these backslash characters could give us trouble, when we URL encode it, those backslash characters get converted to the percent character values. So %3a is the colon, %2f is a backslash. You can see all the backslashes have been replaced with @2f. So that's enough about encoding. Let's talk about encryption. We would start with symmetric encryption. And with symmetric encryption, what you do is you take some plain text and you take a key and you encrypt the text. You then transmit that data to whoever you want to send it to. They take that same key value and they use that to decrypt the value, the encrypted value, back to the plain text. And that's why it's called symmetric encryption, because we're using the same key to encrypt and decrypt. The advantages of symmetric encryption is that it's very fast and can handle very large amounts of data, 250 million terabytes. That's a lot of data you can encrypt. The downside is that you have to take that key that you used to encrypt the string and you have to transmit it to the person who's going to do the decryption. And if something happens in that process, if some third party gets in the middle and is able to obtain the key, or if the person you gave the key to didn't secure it and someone else got a hold of it from them, they could then decrypt your data that you're trying to transmit privately. So that's the downside of symmetric encryption. There's a couple different methods we're going to use to do symmetric encryption, basically encrypt and decrypt. All of these, both the functions take an algorithm, the data that you want to encrypt, and a key, and then depending on the algorithm you want to use, they'll either have they can have an operational mode, they can have an IV and a padding as well. So you need to refer to the documentation for the particular encoding method, or sorry, encryption method that you want to use to determine what you're going to have to pass. So there are let's see, 5 different algorithms supported, and then once again these are the optional parameters. Electronic Cookbook is the default for operational mode. The initialization vector takes zeros by default, and the padding by default is actually varies depending on what algorithm is used. So if you use ECB or CBC, then you get PKCS and etc. So let's look at the alternative to symmetric encryption, and that's asymmetric encryption. Now what happens there, see with symmetric encryption, the key, you could just generate some random text and use that as the key and then transmit it to the person who's going to decrypt the data, and then they would use that key. The key that you use for asymmetric encryption is a little more complicated. There's 2 keys. There's a public key and a private key. So what you have to do is you actually have to generate these, or obtain them from somebody who generates them, because they have to be able, the private key has to be able to decrypt the data that's encrypted by the public key. So there's an algorithm you need to run in order to generate this key pair. So what you do if you want to get data securely transmitted to you is you generate this key pair, you send the public key to the person who's going to send you data. They encrypt the data, they send it to you, then you use your private key to decrypt it. Now what's important here is the public key can't decrypt the data, it can only encrypt it. So if somebody gets a hold of that public key, they can't decrypt the data that got transmitted. You're not giving that private key away, you're keeping it to yourself, and so the risk of having that key intercepted somehow and used to decrypt the data is a lot less. The downside, though, of this particular encryption method is that it can't handle very large amounts of data. 117 bytes of data can be asymmetrically encrypted with a 1024-bit RSA key, or 245 bytes of data using a 2048-bit RSA key, and that's typical sizes for the key pair is this range. So you can't really encode much data, and it's also very slow compared to symmetric encryption. So how do people deal with that? Well, what they do is they often use a hybrid encryption model. What you would do is you would encrypt the data symmetrically, your large block of data symmetrically, using a key that you can share. You're going to take that key, that symmetric encryption key, and you're going to asymmetrically encrypt that. Then you can send the data and the symmetric key that are both encrypted. The data is symmetrically encrypted, the key is asymmetrically encrypted. You transmit that. The recipient uses their private key to decrypt the symmetric key, and then uses the symmetric key to decrypt the data. Because the symmetric key was encrypted in transit, it means that the data is more secure, and you can still do it very quickly because you're using symmetric encryption. So let's see how we do asymmetric encryption. Once again, two methods. Once again, they take UTF-8 encoded blobs and return UTF-8 encoded blobs. There's not quite as many arguments. There's the algorithm you're going to use, the variable, that's the data you're going to either encrypt or decrypt, and then if you're going to encrypt, you're going to use the public key. If you're going to decrypt, you're going to use the private key. Okay, and there's two methods for asymmetric encryption, RSA and Robin, and then the two keys. Now the question is, where do you get these keys? There's a lot of different places you can get them, but one of them is from PowerBuilder itself. PowerBuilder has a function, asymmetric generate key, that can be used to generate the private and public key. The arguments here are the algorithm you're going to use for generating the key pair, the length that you want the key pair to be, and that's typically 1024 or 2048. And then these last two values are actually passed by reference. This is where you're going to get the private key and the public key returned to you. Now I'll point out here that this method takes three algorithms, RSA, DSA, or Robin. For symmetric encryption, you only use RSA or Robin. DSA isn't a symmetric encryption algorithm, it's a asymmetric signing algorithm, and that's actually the next thing we're going to cover. So what asymmetric or symmetric encryption does is it preserves the privacy of the data as it's being transmitted, so that hopefully the only person that can decrypt the data is the person who receives it. Well, the person receiving that data, how do they know the person who says they're sending the data is actually the person they think it is? That's what asymmetric signing does. Asymmetric signing, if I'm going to send you data, that's how you verify that I am the person who actually sent it. So it's almost like asymmetric encryption. The difference is what we do is you actually take a sender private key and sign the data using the sender private key, and then the sender's public key is what's used to decrypt the data. So if I'm sending you data, you send me your public key for me to do the encryption, but I send you my public key so that you can verify the signature. Hopefully that made sense. So what you do is when you're signing data, you take a hash value of the data. You use the private key to encrypt that hash value. You then send it to the person you're sending the data to. What they're going to do is they're going to calculate a hash value for the data they received, and then they're going to use the public key to decrypt the hash value that you sent them, and then they're going to compare those two hash values. If those two hash values are equal, it's a sign of not only that the person who said they sent it is actually the person that's sending it, but also the data came across intact. That something didn't happen to the data in the meantime. So there's a couple different methods on the cryptor object that we use for encryption and signing. They are asymmetric sign and asymmetric verify sign. So if you're going to be signing the data as you're about to send it, you would run the algorithm, pass in the algorithm, the variable that's the actual data, and your private key, and then the person that's receiving the data would run the asymmetric verify sign, specifying the algorithm, the variable that has the data, the sender's public key, and the value that you sent that was returned by this function that they're going to compare against. So this is the case where you can use DSA. You can use RSA and Robin as well for symmetric signing, but DSA can only be used for signing, not for encryption. So once again, you'll get a UTF-8 encoded blob from the asymmetric sign. You're going to send that to the person who's going to be receiving the data. They run to the verify sign. The verifying sign just gives us a -1 or a 1, indicating whether or not the data was received correctly and the identity of the transmitter was verified. So the last idea here, the last concept here is hashing. So hashing, that was actually mentioned a little bit earlier, is how we do signing. Hashing takes a large block of data and produces a small string of data that is meant to represent the larger data. It's a checksum. There's differences between hashing and checksum, but for discussion purposes, that's the way to think about it. So what you do is if you're going to be transmitting data to somebody, you can hash the data and take that hash value, and when you give the person the data, you can give them the hash value as well. So when they receive the data, they calculate a hash value for the data, and they compare it to the hash value that you said it would have. And if the two hash values agree, that means that they got the data without the data being corrupted. If you go to a lot of download sites nowadays and you'll see a link to download a file, oftentimes what you'll see next to it is an indicator of a hash value for that file. And that's what that's for, so that you can validate the integrity of the download once you've received it. So there's 3 different methods of doing hashing. Now the important thing to note, though, is that this isn't like encoding or encryption. There's no dehashing. You basically, like I said, you're calculating a checksum. If you calculate a checksum on a file, you can't take that checksum and somehow de-checksum it and get the file back. It's a one-way operation. So there's no dehashing to get back the original data. So the 3 methods are MD5, HMAC, and SHA. MD5, you just pass the variable. For HMAC and SHA, you pass the algorithm you want to use. And for HMAC, you also specify a key. So there's a whole bunch of different HMAC and a whole bunch of different SHA algorithms that you can use to do the hashing. Okay, before we get to the question and answers, I just want to show you what some of this stuff looks like real quick. So this is encoding. Okay, so here's a block of text, and I'm going to run a hex encode on it, and so we get all the ASCII values, and the spaces are represented by the 20s. And now I decode it, and I get the text back. I could do a base 64 encoding on that, and you get this string, which we can decode back. And then finally, here's a URL, and you saw it from the slides as well. And then this is what the URL looks like when it's encoded. Okay. This is that same block of text. I'm going to do symmetric encryption on it. So this is what I get, and I can decrypt that value. Number of different algorithms we can use here. Notice the key is just a bit of random text. I could replace that with a different bit of random text and it would still work. Asymmetric encryption. Notice now this public key and private key I got by using that async key generate method in PowerBuilder, and I just pasted the values that it generated in here. So now notice I'm doing a lot less data. I don't have that big block of data. I've only got this small text here. I encrypt that, and that's what I get. And now I can decrypt it. What I do is this clears out this little text area, and then takes and decrypts this back into there. So it makes you can see you get the same data back out. Now I'm going to take this data then and sign it. And this is what the signature, the asymmetric signing gives me. And then that's the hash value. Then when the verify sign, what we're going to do, what PowerBuilder is doing internally is doing a hash on the data value that it got, the encrypted data value it got, and then it's going to compare it to the hash value that it received and to indicate whether or not that was valid. So it said it worked. And then finally hashing. So here's that big block of text again, and this is what an MD5 hash, for instance, looks like. This is one of the SHA hashes right here. Okay. Okay, so that's enough for that. Let's go back to the slide, slides. Yeah, and we have the question and answer session now. So I'm going to turn the things back over to Armin.